In the previous lessons, we learned about pH and pOH. Now we are going to learn about how pH and pOH are related. That is, the values of pH and pOH, they added together equal to 14. And remember, when we calculate pH or pOH, we need to realize if the solution is made from dissolving a base, which we use to calculate for pOH, but if a solution is made from dissolving an acid, we have to calculate the pH first. So let's look at this problem. Calculate both pH and pOH from the concentration of each solution. In this case, remember, P is equal to negative log of anything, right? In this case, if it is pH, we are referring to the negative log of H plus ions, and pOH is referring to the negative log of the OH minus ions. So in this case, this is an acid, so it's gonna be pH. So in this case, the pH is equal to negative log of 0.05. And if we plug this into a calculator, let's use Google Calculator. What we have? We have negative log of 0.05. Enter. So the pH in this case is 1.3. So 1.3 is equal to pH. So if we plug into this equation, where 1.3 plus pOH is equal to 14, what is the values of pOH is going to be? Well, 14 minus 1.3, and that would give us what? 14 minus 1.3 give us 12.7. So we have 12.7, that is our pOH right there. Now, let's try another problem where in this case I have a base. So in this case, it is gonna be calculating the pOH first. So we have pOH equal to negative log, in this case, is 0.05, and it's the same value, so we know it's gonna be what? It's gonna be the same answer, 1.3. I don't even need to use a calculator for that one. So in this case, we have the same equation, pH plus pOH. In this case, pH, we don't know, but we know that pOH is equal to 1.3, and that's equal to 14. So your pH must be equal to 14 minus 1.3. What is that gonna be? Oh, look, the same math again. In this case, we have 12.7. So in this case, we have a solution made from a base, and we solve for pOH first, and then from there we can solve for pH, which is 12.7, which is very basic. Let's try another problem with scientific notation. In this case, we have 1.5 times 10 to the negative 5, and this right here is an acid, so we had to calculate for pH. So in this case, we have negative log of 1.5 e to the negative 5, and let's plug into a Google calculator. Now let's plug into a calculator. We have negative log of 1.5 e, which is exponent, and that's negative 5. And then what do we have? We have 4.8, if I remember this correctly. So 4.82, let's use 4.8. And in this case, if we have our pH, which 4.8 plus our pOH equal to 14, that means the pOH must be equal to 14. We just bring this over here, 14 minus 4.8, which in this case is going to be what? 14 minus 4.8 equal to 9.2. So that is the values of pOH. Now let's try in this case where we have a base. And notice how the values is the same thing to prove to you that the concentration, even though it's the same, but the substance is different, it would change the whole entire nature of the solution. So in this case, we have pOH, because it is a base, equal to negative log of 1.5 e to the negative 5, which is the same math. So therefore, it's equal to 4.8. But now, pH plus pOH, which is 4.8, equal to 14. So we bring that over. pH is equal to 14 minus 4.8 again. In this case, what do we have? We have 9.2. But in this case, the 9.2 is for pH. That represents that this solution is very basic. Where over here, when we make from an acid right there, notice how we have the pH equal to 4.8, which is very acidic. So you have learned how to calculate pH or pOH using the relationship between pH plus pOH equal to 14. Now, what if we don't look for those pH or pOH? What if I want to find the concentration? So if you notice, P is equal to negative log with a base of 10 to the concentration. And in this case, it's the same thing for pOH. Now, how do we find the inverse of this? First of all, we have to realize that this negative can be bring over here. And then we just gonna have negative P, and then we just gonna have log of 10. Now, how do we simplify this equal to 1? Well, there is one logarithm rule that allows us to do that. Basically, we take that base right there. Notice how the base is 10. If we take that same values and we take 10 to the log with a base of 10, that would equal to 1. So now, if we take 10 to the negative pH equal to 10 to the negative log of 10 equal to H, this will simplify equal to 1 and give us our concentration in H+. Isn't that easy? And you can do the same thing for pOH as well. Let's do this one. Let's do the same thing to the pOH. First, I bring the negative over. So I have negative pOH equal to log 10 to the concentration of OH minus. Now, how do I get rid of this? I put 10 to the power of this, which is the same as the base. That simplified equal to 1. And I do the same thing on this side as well. So therefore, our concentration of OH minus is equal to 10 to the negative pOH. And that's how you go back from pH or pOH to determine the concentration. So let's try a problem. In this case, I have pH is 5.1. So what is the values of H plus gonna be? So in this case, what we have here is 5.1 equal to negative log of concentration of H plus. So therefore, I bring the negative over. I would have negative 5.1. So let's change this color right here. Let's remove that, okay? And I put the negative right there. And the next step is I know that the base is 10. So I'm going to put 10 to the power on both sides. So now let's plug in our calculator. In this case, our H plus concentration is going to be 10 to the power of negative 5.1. And plug into a Google calculator. We have 10 to the power, which in this case, the exponent is this one right here, and negative 5.1 equal to the concentration, which is very small. We have 0.000079, so that's like 50. So then you have 0.000079, and that is a concentration of H plus right there. Let's do the same thing in this case. But now I don't have to do this work anymore because I know to find the concentration of OH minus, all I have to do is take 10 to the power of negative, in this case, is pOH, which is negative 11.5. So let's plug into a calculator. See, now we have 10 to the power, which is negative 11.5. And what do we have? A very small number, which in this case, 3.16 e to the negative 12. So equal to 3.16 e to the negative 12. There you go. And that would be the concentration of OH minus. Let's try another one. Here I have pH, right? I'm not going to show this work again because I know the pattern already. So the concentration of H plus is equal to 10 to the power of negative pH. In this case, 2.7. So this is right here, okay? And let's plug into a calculator. 10 to the negative 2.7, which gives us 0.001, which is 0.002. 0.02. And there you go. And that would be the concentration. Now let's try another one. In this case, we have OH minus is equal again to 10 to the power of negative pOH. And we know that 10 to the negative pOH, which in this case, negative 3.5. So what do we have? Plug into a calculator. 10 to negative 3.5. And that's our answer. 0.00316, which is 0.0032. 0.0032. And that's how we solve from pH or pOH to the concentration of H plus or OH minus.